doing? I'm your man, John Wilson. Today we're going to work with rotations on the coordinate plane. Rotations, pretty simple. We're rotating figures around the origin. You're going to see how that works right now. Okay, so when we rotate a figure, we're only going to rotate it at this grade level in one of three ways: 90 degrees, 180 degrees, or 270 degrees. Now, if you did 360, that's a full circle, you'd end up where you started. We can rotate figures clockwise, which means in rotation only the position and orientation change. We don't change the size, we never ever ever change the shape. Now, we rotate clockwise or counterclockwise. Clockwise, like the way the hands of a clock move. So if we started here with triangle DEF and we rotated at 90 degrees, then 180, then 270, 360. We're rotating it clockwise, like the way the hands of a clock move. We can also rotate a figure counterclockwise, which would be opposite to the way that hands move on a clock. So if we started here, counterclockwise 90, then again, 90, 180, 270, 360, back to where we started. So clockwise or counterclockwise, it is important. Clockwise primarily in a circle moving to the right. This is in a circle moving to the left. When we rotate a figure 90 degrees, whether we're doing it clockwise or counterclockwise, it's only going to move one quadrant. There's 4 quadrants on a coordinate plane. A rotation of 90 degrees moves it one quadrant around the origin. For 180 degrees, it's like the same thing as reflecting a figure across the origin. It's going to move 2 quadrants. Doesn't matter if you go counterclockwise or clockwise, we're going to move 2 quadrants. For 270 degrees, well, that's 270 degrees clockwise, the same as 90 degrees counterclockwise. 270 degrees counterclockwise, the same as 90 degrees clockwise. And we're going to be moving 3 quadrants. So 90 degrees 1, 180 degrees 2, 270 degrees 3 quadrants. And if you go all the way around the world and you did 360 degrees, you would be moving, yes, 4 quadrants. So it's important to know how you move in a rotation graphically. Whether you're moving clockwise, counterclockwise, 90, 180, 270, 360, it gives you a pretty good idea of how you're moving. Also keep in mind here that the orientation changes. If you were to think of this shape as a little arrow pointing this way, when you rotate it, now it's pointing down to the left. Here it was down to the right, down to the left. If you rotated it this way instead, now it's pointing up and to the right. So it's important to know that not only will the position change, but also the orientation will change. So for interactive practice, we can try something like this. I can take this figure. Let's say I want to take this and I wanted to rotate it 180 degrees around the origin. So this is the origin. If I rotated it 180 degrees, it would end up right there. Doesn't matter if I go clockwise or counterclockwise. And it really doesn't matter what shape I use. If I were to take this figure and I were to rotate it, let's say 90 degrees. You want to go clockwise? Okay, we'll go clockwise. If I were to rotate this 90 degrees clockwise, let's see what would happen. So I have this figure here. Let's turn U, and we're going to rotate this 90 degrees clockwise. Notice that I moved one quadrant and the orientation changed just a little bit. So graphically, they're not hard. Let's talk about algebraically. To do a rotation algebraically, you have to, once again, multiply the coordinates by -1, but you're also going to rotate the coordinates or switch after you multiply. Let's see how that happens. So, when I'm doing a 90 degrees clockwise rotation, it's the same as doing a 270 degrees counterclockwise. If I did that, I would have to multiply each of the x coordinates by -1. So 90 degrees clockwise, I'm multiplying the x coordinate by -1, and then I'm rotating or switching the coordinates in my final answer. So 3, 4, same point. I would multiply the x by -1. That gives me -3, 4. But I'm not done yet. For my final answer, for my a prime, I have to flip those coordinates. So it's not going to be -3, 4. It's going to be 4, -3. And that's the coordinate notation that we use for this. Notice that the y and x have switched places, and I multiplied the x by -1. Here I have 3, 4, 90 degrees counterclockwise. Here I'm going to multiply the y coordinates by -1. So I take 3, 4, I multiply 4 times -1, and I get 3, -4. I'm not done yet. Now I rotate or switch the coordinates, and I get A prime at -4, 3. And here's the coordinate notation for that. If I'm doing a 180-degree rotation, it's the same as doing a reflection across the origin. I simply multiply the x and y coordinates by -1. No switching required here. I multiply both the x and y coordinates by -1. That gives me A prime at -3, -4. So notice here I had to switch 90 or 270. Here I had to switch 90 or 270. When I do 180, I don't have to switch. And if I do 360 degrees, nothing changes because I end up exactly where I started. Let's try a sample problem. Let's say we want to rotate the figure 270 degrees clockwise, algebraically, and identify the coordinates of A, B, C prime. So if I'm going 270 degrees clockwise, so I'll be multiplying all of these by -1 and then switching. That's going to give me 4, 5 times -1. That gives me 4, -5. And then for my final answer, I rotate. So I don't have 4, -5, I have -5, 4. Multiply, then switch. Multiply, then rotate. Whatever way you want to remember it. But remember that before you write your final answer, you flip those coordinates. You rotate them. So I go to B. -3, 2. Same thing. I multiply the y. -3, 2 times -1. That gives me -3, -2. Multiplication's done, and then I rotate the coordinates. -2, 3. That's actually -3 right there. I guess we missed that one, huh? All right. -8, -1. So multiply and switch. What we're going to do here is we are going to take this same thing, -8, -1 times -1. That gives me -8, 1. So I did the multiplication. Now all I have to do is switch, and I end up with 1, -8. Question: which of the properties of transformations are affected by rotations and reflections? There's only 2. You got one of them? What properties? Position, size, shape, or orientation. That's one of them, position. What about the size? Nope, that's only a dilation. The shape will never change. The other one is an orientation. Thank you for watching Rotations. See you next time. Don't forget to like the videos, leave a comment, share it with your friends, and of course, subscribe.